3.
இதை மாத்திட்டு அந்த மெக்கானிக் ஒர்க் ஷாப்னு ஒரு வேர்ட் இருக்கு பாத்தீங்களா?
So good evening, sir. Shall we start, sir? Okay, sir. So respected principal, sir, respected vice principal, sir, esteemed chief guest, distinguished resource person, dear faculty members, research scholars, and industry experts. Good evening to one and all. It gives to immense pleasure to warmly welcome you all to 6 days faculty development program on data science for LLM and generative system organized by Department of CSE, SRMTRP Engineering College in association with IEEE student branch, and a data alchemist. This FTP is thoughtfully designed to bridge theory and practice in the rapidly evolving domain of LLM and generative AI. And we are confident that the session will enrich participants with the contemporary knowledge, tools, and research insights. On behalf of the department, I extend a cordial welcome to our honorable chief guest, respected management, resource person, all participants. We sincerely hope this FTP will be an engaging and intellectually rewarding experience for everyone. Thank you. Welcome to once again, sir. Anman. Sir, presidential address is given by the our principal, sir.
Yes, madam. Yeah, very good evening to all the faculty members who have joined in this 6-day faculty development program on data science for large language model and generative system. So I hope that all faculty members know after your college hours you are attending this program. We have arranged so many experts people, so they may be sharing their knowledge in LLMs. So I request all the participants actively participate. So because namesake, please do not join in the program. You please participate actively. So whatever the hands-on exercise given by the expert now, try to solve it. Okay, all the best. Thank you, madam.
Thank you, sir. Thank you, sir.
Please carry on.
Thank you, sir.
Hello.
Madam, mic mute la irukku, madam. Suganya, madam, mic mute la irukku.
Thank you, sir. Thank you, principal, sir. HOD, sir, given a welcome address, sir.
So good evening to one and all. So it is my pleasure to deliver the welcome address for today's 6 days faculty development program, Data Science for Large Language Model and Generative Systems, organized by Department of Computer Science Engineering, SRM TRP Engineering College. So let me offer a respectful welcome to our beloved chairman, sir, in absence here. I offer my heartful welcome to our chief guest, Swarnalata Krishnamurthy madam, lead technical program manager and vice president, JP Morgan Chase, USA. Welcome, ma'am. I offer my heartful welcome to our keynote speaker, Ms. Raghavi Sendil, software developer, Sycamore Informatics, Boston. Welcome, ma'am. So let me offer a welcome our beloved Pro VC sir, Dean Academic sir, and Dean Research sir in absence here. Let me offer our respectful welcome to our beloved Principal Dr. M. Sivakumar sir for his full backbone support for our conducting the FDP programs. Welcome, sir. Let me offer a respectable welcome to our beloved Vice Principal Dr. C. Ramesh Kannan sir. Welcome, sir. I am delighted to welcome FDP coordinators, Mrs. T. Suganya madam, Mrs. M. Subhasri madam, all the CSE faculty members and SRM TRPC, various faculty, department faculty participants, and other college participants from various Tamil Nadu and other state also. We welcome you all on behalf of SRM TRP Engineering College, Department of Computer Science Engineering. Once again, I welcome you all. So please make use it 100% effectively and efficiently. So thank you once again. Welcome you all. Thank you.
Thank you, sir. Let me go on chief guest introduction. It is our great honor and privilege to introduce today's chief guest, Ms. Swarnalata Krishnamurthy, a distinguished industry professional and an inspiring leader in the field of information technology. Ms. Swarnalata Krishnamurthy holds an MBA in IT management and brings her over 2 decades of rich industry experiences. She began her professional journey with the Citibank through Polaris, where she served for 8 years, gaining strong expertise in enterprise system and financial technology. She then joined JP Morgan Chase, where she has been contributing for nearly 12 years, playing a wide range of roles, including software developer, technical lead, project manager, and currently as a program manager for public cloud migration. Her career stands as a fine example of continuous learning, leadership, and adaptability in the ever-evolving technology landscape, particularly in large-scale enterprise and cloud transformation initiatives. Beyond her professional accomplishment, Ms. Swarnalata Krishnamurthy is also an inspiring role model who beautifully balancing her personal and professional life. She is proud of mother of two boys and wife of nephrology doctor. She moved to US in 2011, where she continues to make significant contribution to global IT industry. We are truly privileged to Ms. Swarnalata Krishnamurthy with us today, and we are confident that her insight and experiences will greatly inspire our faculty members, research scholars, and industry experts. Let us warm welcome our esteemed chief guest, Ms. Swarnalata Krishnamurthy. Welcome, ma'am. Ma'am, your mic is muted, ma'am.
Oh, sorry.
Unmute, please.
Can you hear me now? Can you hear me?
Yes, ma'am. Yes, ma'am.
Good evening, everyone. I know we are already a few weeks into the January, but I hope the new year has started off exceptionally well for all of you all. Thank you, Siganya. It's a great pleasure to be start like my 2026 with the people who really shape the next generation of engineers. Thank you for inviting me to this part of this program. Like as she gave the quick intro, I don't want to take much time. So I'm Swarnalata, currently working with JP Morgan Chase, which is the world's largest bank. You all might know. Right, like I am in this industry for almost 2 decades now, and all my experience into banking industry only. So let me, I think, quickly start giving you a quick sense of what is JP Morgan Chase Bank and our technology culture does. So, as you all might know, JP Morgan Chase is one of the world's largest financial institution in the world. We serve millions of customers and a small business and corporations and government across the like more than 100 markets, I would say. See, most of the people think that we are just the banking industry, but it's not really like we are really a tech, like I should say, we invest a lot in technology and we are a largest technology center as well, actually. The company invests almost $15 billion annually for just the technology perspective alone. They employ tens of thousands of employees across technologies, engineers, data scientists, and cybersecurity experts across the world. JP Morgan Chase technology is not just a support function, it is the main one of the business for them. Like digital transformation is deeply embedded in our culture, actually. So coming to AI and data science, like those are the heart of this transformation, I would say. So data science really helps the bank, I would say, mainly to understand the customer behavior and managing the risk and optimizing the operations. And AI does allow us to automate decisions and detect patterns which human cannot really predict or see and deliver personalized experiences. So without advanced AI or the machine learning, I think none of these would have been possible for us. So one of the most mature area is like the fraud detection is the main important thing for the banking sector, I would say, where LLM and AI are in use for us. Every day, considering the banking, we do billions of transactions flow through the systems. Machine learning models really analyze the patterns in the real time to detect the suspicious activity. These systems learn continuously so that it adapts to new fraud strategies, risk modeling, like that is the another critical use case for the banking. So we use advanced models to evaluate the credit risk and the material risk as well as the operational risk. Also, these models help the bank smarter, like make the decision on the lending as well as manage the exposure in current volatile markets, actually. So AI models as such, it analyzes the market signals at high speed, which makes the which really helps the traders to make the informed decision. So in the customer service business, mainly how it helps is they use a lot of chatbots, so which handles the main routine requests what the bank handles, so that the allowing which helps the humans agents to focus on the real complicated cases. So bank does process thousands of legal documents on a daily basis, extracting key classes, identifying the risk, and flagging anomalies on a real time. So AI saves thousands of hours of manual review at the banking sector. So internally, a company like JP Morgan Chase itself built a secure AI platform because that allows the teams to experiment safely the AI models while meeting the strict security standards and the regulatory standards what the government and the law has it actually. So I don't want to go more into confidential level, but what I can say is the enterprise AI looks very different than what we really see in the demos. So, and as like when it comes to Chase, the uses of LLMs, like these in the 2020 early, we start with like 100 employees, but if today they implemented like they make use of the LLMs for the 200,000 plus employees around the world. So that's one of the greatest achievement Chase has made, and we are like proud to say that we are ahead in the AI race in this world as per the banking sector. So I think what we would really focus on to see like how we can bridge the academic to the industry level. So from the industry perspective, I think we are looking for the graduates, what is like, who are not just theoretically strong, but practically skilled actually. So machine learning, I would say fundamentally matters more than fancy algorithms, like understanding what the data pre-processing happens, evaluation predictions, and the metrics and the model limitations are the real critical standards that we look for currently today. So being here, like I'm being here, I think really matters because the future of technology is not just the company produced. I think where they really have their base, like the education center, the college are the one who really shapes up the better engineers. So one second, sorry. So what I would say to the faculties mainly is like make the students make them understand more rather than just creating the models or whatever it is, how they really deployed, how they really trained, and how the responsible AI is playing the role, because that's not an option anymore for us in the world. So for students, career preparation should really start early, I would say, because right now in the AI world, there are many roles like the data analytics, data engineers, learning engineers, and a product managers, as well as research scientists. Those like many, even within Chase, like we have multiple labs who just does the AI research today. So make the students prepare them well, create them the different skills, build them the strong fundamentals first actually. So make them master in the Python, statistics, and the data structures. Participate in many of the hackathons, like our Chase does conducts many hackathons on a regular basis. So I would strongly recommend all the students or even the faculties to attend one of the hackathons and make them aware what the industry is expecting and how far we are on actually. So as you all know, like whatever we learned today may be outdated for like within a couple of years. So I would suggest every student make a continuous learn. That is the only thing that's going to really help us. So as the AI is really reshaping the entire industry, it's really matters how we really use the AI sensibly and I would say more considering the risk in place. So you as educators have the immense responsibility on this, I believe. So you not only just shape the skills, I'd say you also add the values. So teach the students to build responsibility, teach them to really question the models, and teach them to think critically. So as the students, I would say let them dream big so that they can be in a place where anyone is dreaming today. So thank you. I think thank you again for inviting me, Sidanya. I'm looking forward to an engaging discussion further. Yeah.
Thank you so much, ma'am. You've given a very inspiring thought about the LLM and AI, ma'am. Thank you once again, ma'am, for coming to my chief guest also.
Thank you. Yeah.
So the session is move on to the vote of thanks. Okay, the vote of thanks is given by our one of the coordinator, Miss Subhasri. Subhasri, ma'am.
Yeah, good evening to everyone. It's my privilege to propose the vote of thanks for the 6 days faculty development program. First, I would like to express our deepest gratitude to our chief guest, Ms. Swarnalata Krishnamurthy ma'am, for sharing such insightful and thoughtful provoking ideas with us today. A special thanks to our management and organization for their constant support and guidance, making this event a reality. I must also acknowledge the HOD sir and our dedicated volunteers who work tirelessly behind the scenes. So finally, I thank our audience to have a active participation to make the event very success. Thank you.
Thank you, ma'am. Uh, on the behalf of our FDP, day one session is started. So day one session topic is core data science technique for LLMs using Hugging Face and NLP libraries. So our resource person is Ms. Rahavi Sandal, software developer, working in a Cyram Core Informatics in Boston. Ms. Rahavi Sandal, kindly continue this session.
Yeah, thank you so much for that warm introduction. So, good evening, everyone. Thank you so much for joining today. My name is Raghavi Sindhil, and I am a junior software developer at Sycamore Informatics. So, I work on clinical data platforms, and most of my daily job is revolves around developing agentic AI systems. So, when I say agentic AI, I literally mean AI agents that can think, decide, and then perform tasks automatically. So, for example, I have built agents that can convert SAS code to Python, validate clinical data set, analyze regulatory document, and then even assist in generating reports. So, we work with pharma clients, real healthcare data sets, and real clinical trial workflows. So, what I want to say is that maybe in this 6 days, you will not only get to know the conceptual clarity, but also you will get to know what is really happening in industry level. So let's get things started. So before that, let me share my screen. So please confirm if my screen is visible.
Yeah, it's visible, Rahavi.
Okay, thank you for confirming. So today I want to take you on a journey, not just through models, but through how thinking in machine learning has changed from classical machine learning to deep learning and then to foundation models and finally to LLMs. So let me start with why this session matters. Today, students don't get excited just by accuracy numbers anymore, right? Earlier, 92% accuracy was impressive. But now they ask, why can ChatGPT write essays but my model can't? So faculties are under pressure not only just to teach tools, but to explain why these tools and how these tools work. So that's why today we focus on concepts and not specifically on any libraries and APIs because they change every year. So, but the core ideas like embedding, attention, and then prompting will stay. So, I think we'll focus on core concepts today. So, first, let's rewind and we'll go through an evolution journey. So, in classical machine learning, we manually created features. We made machine learn features manually. Then, in deep learning, network started learning features, and then in foundation models, one model learns everything. And today we literally talk to models in English. Right? You agree? So that shift is massive. Earlier we trained models, but now we instruct models. That's why even your role as an
Rahavi,
educator.
screen is closed, Rahavi. Kindly share your screen. Ah, yeah,
Is it
now visible.
yeah? Thank you.
Ah,
So that's why, as an educator, your role is also continuously changing. So from teaching codings to teaching reasoning and how to communicate with AI. So let's dive deep into classical era. So in classical machine learning era, domain knowledge was king. If you worked in healthcare, you manually engineered features like BMI ranges, cholesterol ratio, and blood pressure. Datasets were small and models were specific to one task. So if you want to predict diabetes, you train one model. And if you want to predict heart disease, you train another model. So every new problem meant starting from scratch. So performance depended more on feature quality. So when I say feature quality and feature engineering is done by humans manually. So classical ML era is fully dependent on human intelligence. Then came deep learning. So here CNN started learning images automatically, RNN started learning sequences, and then suddenly we didn't have to engineer features manually. They automatically started learning features. But still we had problems. We needed massive labeled data sets and models were brittle outside training data. When I say models were brittle outside training data, it literally means that if I train a model for performing something related in medical field and then I take the model, go to finance sector, if I use the model there in finance sector, will it perform well? No, it fails. Every new task requires retraining. So even though deep learning was powerful, it wasn't flexible enough. In industry, this actually became a nightmare. Like labeling costs was too high, and one labeling data set could cost more than $100,000. So training cycles took months. So now imagine pharma, one model for oncology, one for cardiology, and one for neurology. Do you think maintenance is easy? Not at all. Maintenance became impossible. That's why industry started searching for better solutions. Then came foundation models. These models are trained on everything, literally like books, Wikipedia, articles, news, and even human conversation. So these models are trained on internet scale data. So one model can summarize, translate, reason, code, and answer questions. So here, zero shot learning became possible. So we train new models, we just prompt them, right? Just prompt. That's why ChatGPT shocked the world. So it showed that one model can do everything. So here, what is really fascinating is the same model can write poetry, solve math, summarize research paper, and words. So this is why prompt engineering still exists, because we just change words. We don't program, we don't change weights, we just change words. So if I say summarize, it summarizes. If I say give me the code, it gives code. So we no longer programs. We don't actually have to program each and every time. We just prompt it. So if I go back and compare classical ML era and today's LLMs, the old world was data centric training, and new world is full of prompt centric usage. Earlier pipeline was like collect data, label, train, and then evaluate. But today it's like write prompt, test, refine, and deploy. So the skill shift is huge here, from coding to thinking and from syntax to intent. So now I'll show you some of the core concepts behind LLM, like tokenization, embedding, prompting, attention, and transformers. So let me switch to Google Colab. I hope my screen is visible.
Yes, yes.
Yeah. So now watch carefully. Here I have given My cat is pretty cute, right? So human sees this as a sentence, but do you think machine also gets this as a sentence? No, machine splits this sentence into multiple chunks, and those chunks
Ma'am,
are called as
your screen is invisible, ma'am. Your screen closed, ma'am. Please share
okay.
your screen. Oh, okay.
Yeah, yeah, thank you. Yeah, my cat is pretty cute. Do you think that mission sees this as a sentence? No. Each sentence will be divided into multiple chunks called as tokens by machines. So when I run this cell, look at the output. So even the exclamation mark became a token. This is important because companies charge per token. For example, ChatGPT, Claude, Gemini all charge by tokens. So it increases the billing. In my company, when we build AI agents for pharma clients, we literally optimize prompt to reduce token costs. Next is embedding. Embedding is, see here, the sentence are divided into tokens, and then here those tokens are converted into numbers called vectors, and this process is called as embedding. So let's see what happens here. Here I have given some words. For example, king, queen, prince, princess, apple, banana, orange, car, bus, and train. So here these meanings are converted into math numbers. So then I reduce dimension using PCA so we can visualize it. So actually in missions, there are multiple dimensions, more than 390 dimensions. So if we need to view it, we have to compress them into 2 dimensions. So I'm using PCA. And then when we try to visualize what we gave, see there are clusters here, here, here. And see the clusters. Royal words clusters together, fruit clusters together, and vehicles clusters together. Did I give that these are vehicles, these are fruits? No. The model automatically learned from internet scale data. So this is how resume matching works. This is how clinical document search works. And this is how drug classification works. Everything is based on vectors. So next we'll see one more interesting topic related to prompting. So now I just gave a prompt, artificial intelligence is, and then I let the machine model continue. See the output. So if you see the output, it's very generic, right? It started randomly. It started continuing my sentences, but then when I gave a prompt like this, explain artificial intelligence to a 10-year-old kid using an example. So see, same model, same GPT model, but completely different output. This is called as soft programming. That's why prompt engineering really matters. So in industry, we actually use this for doctor chat assistant, customer support bots, and automated report generation. So that's why soft programming, prompt engineering is not a nice to have skill anymore, but actually a need to have skill. Then token counts. So now see, short prompt, I gave 2 prompts here, short one and the long one. And short prompt has fewer tokens and longer one has 8, like more number of prompts. So in an enterprise system, this actually directly impacts billing. So prompt optimization is also really important for a machine learning engineer or AI engineer. So we saw word embedding previously. Now I have given sentences. So I have taken few sentences like I love pizza, I enjoy burger, machine learning is fun, and AI models are amazing. So look at the plots here. See again, X sentences clustered here, and then food related sentences got clustered here. This is how actually the recommendation engines work. For example, if you use Netflix, Spotify, all those actually recommends through this method. So in healthcare, symptoms clustering uses this to detect similar patient cases. And one more important topic is cosine similarity. So see, the similarity between these sentences or words are actually measured by cosine similarity. I don't want to dive deep into math as today's foundation day. So I'll just give you an overview. So it ranges from 0 to 1, and 1 means identical. 0.5 means somewhat related, and 0.2 or 0 means totally unrelated. So we use this to match.
Ma'am, screen invisible, please share, ma'am. Please, screen closed, ma'am.
Sorry again. I don't know why this is continually happening.
Yeah. Sometimes the screen.
Yeah.
Now it's okay, ma'am.
Okay. Thank you. So yeah, as I said, we actually in industry use this method to match patient symptoms, research papers, regulatory documents, and this is actually backbone for all these search engines and recommendation engines. So next topic is attention. So if I say children are playing in the garden, and if I ask where the children are, you obviously know they are in the garden. And if I ask you what are they doing, you would answer me they are playing. So you know whether to focus on playing or the place garden according to the question. But how does the machine knows which word to focus on? So that's where attention actually helps machines. So attention actually helps them to wait which word to focus on, and it allows the machine to understand the context and answer based on the query. So here I have given John gave his brother the book because he was moving. So see the bars. So actually the machine focuses on gave book because he was moving. So these words are given more weights than the other words. So attention actually gives context awareness. So in clinical AI, in our company, model focuses on diagnosis, dosage, and risk. If if we need to summarize the entire 10,000 pages of PDF, how do AI know which words to focus on? That's where attention really plays a major role. Next is semantic search. So, have you ever tried chatbots? Have you ever seeked help with chatbots to like literally find some documentations internally in your university or in some other organizations? So, that works with this method. So, I have documents like AI in healthcare, machine learning in finance, and TL in images. So, my query is something related to medical AI. And see, the highest score is the highest score goes to healthcare because medical and healthcare has a semantic match. When you plot this, you can see the highest score goes to healthcare because medical and healthcare are similar to each other. So this is how RAG systems work. Enterprise chatbots search internally they'll just search internal documents this way. So let me go back to my slides. Yeah. So I hope my screen is visible.
Yeah, it's visible, Rahavi.
Yeah, thank you so much for confirming. So yeah, transformers. So before we had LLMs and like some other deep learning and machine learning models like CNNs and LSTM, they actually go through the input documents word by word, each word like how human reads from left to right, word by word. But do you think that it's efficient? They were slow, they forgot long term information, and they could not run efficiently in GPUs. Then came this transformer, and it did a very good job. So, what difference it made is it read all words at the same time, not sequential, not one by one, but all at once. So, together, like everything all at once. So, this is called as parallel processing. And why this matters? Because have you heard about GPUs? They are actually designed to do thousands of calculations simultaneously. So transformers match GPU hardwares perfectly. So that's why companies like Nvidia became so powerful after AI boom. So yeah, these are all the main core concepts of LLMs. So let me move to the final key takeaway. So I think like before we close, I want to like pause here and take questions. If anyone have any questions, please feel free to unmute yourself and ask questions. And I'll also like just reflect on what we actually learned today. So first big takeaway was machine learning is
Screen is.
uh,
Oh. Yeah, now visible.
yeah. So yeah, so first big takeaway was machine learning is no longer just about models, it's about communications. Yeah, because earlier our power came from writing complex algorithms, and today power comes from writing clear instructions, right? So the next takeaway is embedding change everything. When we saw words and sentences turn into vectors, that's not just visualization, right? So that's how search engine works. That's how recommendation engine works. And then we saw about attention because attention is intelligence because it allows model to understand context. And then finally, we also learned about LLM change and how we design ML today as we no longer build one model per problem anymore, right? We build system around models. We combine prompts, embedding, retrieval validation, and monitoring. So AI today is not just a model, but it's like a very huge ecosystems, and that's how our mental model should also shift. So yeah, that's it from my side. Thank you so much for your time, your energy, and your curiosity today. So I would love to take questions if anyone have any questions, or else I'll hand over the session to the coordinator.
Suganya madam,
So, dear participants, yes, sir. Dear participants, if any doubt, you can ask to Rahavi Senthil. Please.
Ma'am, Sonia madam.
Sir, 1 minute, sir.
If no doubts, we can close the session, ma'am. We put a feedback in group.
Okay, sir. So we will wait for 5 minutes, sir, for participants.
Okay.
Ah. So, dear participants, if any doubt, please ask to Rahavi Sindhil. So today session title is Code Data Science Techniques for LLM using Hugging Face and NLP libraries. Please participants, you can ask. If you have any doubt, please ask to Rahavi Sindhil regarding this session. If you have any doubt, kindly chat me also. She will reply. Yeah, Satya. Satya, kindly tell me your doubt, please. Okay. Okay, sir. Give some applications for LLM. Rahavi Sindhil.
So, so applications for LLM, like what kind of applications you're asking about? Because there are LLMs in the sense we have Claude, Gemini. These are all the LLMs that we are currently using today.
So anybody there? Okay, Kalayasan sir. Ma'am, list some more libraries filed in NLP.
Okay, so I'll actually share you my Google Colab and the PowerPoint presentations. I'll also include a lot of libraries and industry level packages so that you can actually go through them and you can also use it and run and see it for yourself. I'll definitely share it with Suganya ma'am so that you can also use it.
Ma'am, Hugging Face. So what are the different applications they are using in Hugging Face libraries? Ma'am?
So actually Hugging Face really helps us in creating a lot of generative AI, like even for building chatbots. So recently, even in our project, we actually use Hugging Face so that it actually detects our hand movements, and we actually created a virtual piano. And when we like act like we play piano, it automatically plays piano. So there are various use cases, and one example is that. So for building chatbots for generative AIs, we actually use Hugging Faces.
So maximum joined in the forum is teachers only. So what
Okay.
way we teach to our students for current trend about the LLM learning and this type of Hugging Face and what type of projects mini use cases will give for students for third year and final year is
Yeah.
better useful for their placements and etc.
Yeah, I'll answer you that. So as I said, nowadays, not only see how not only just thinking of how and what kind of functions I need to use here, what kind of algorithms I need to use here, we actually have to start teaching or start thinking like how to optimize my model, how to actually efficiently use my model, reducing time and space complexity. And also like there are skills nowadays which were nice to have earlier but need to have now. And regarding the training related to LLMs, you have to teach something related to pre-trained models, like uh, because nowadays nobody uses and build models from scratch, right? Nowadays there are a lot of pre-built models. You can like teach them how to efficiently use them and remodel from a pre-trained model. So I think I answered your questions. And any other questions?
Yeah, Ravi. So how can we integrate the LLM as a agent? So Naresh are asking this question in chat.
Integrate LLM in.
As a agent, how can we integrate the LLMs as a agent?
So yeah, so I think for students they actually gave a lot of features in OpenAI and Google Gemini. So you can even get API keys, because generally we build agents using API keys, which can pull API and even pull the data from the real world. So I think really you can use APIs for integrating LLMs in agents.
Real API. Okay. So one more question is Ravi. Uh, what skills should students focus on to build career in LLM based application development? What are the skills should student focus on to build a career in LLM based application development? In student
Okay.
focused.
So, thinking of skills, the first main thing is quality in data. So, this is the first and foremost important thing about LLMs, because if you give a garbage input, obviously you'll get a very bad output, right? So, first thing is how you prepare your data. Like you have to like clean your data set, reduce bias, and then even balance it if it's inconsistent. So first skill is data pre-processing, and the other skill that I have already mentioned in the session is prompt engineering. So how to give a clear instruction, how to control tone, because see, you can evaluate machine learning models with accuracy and it has certain evaluation metrics. But in LLMs, if professor gave a topic and there are 40 students in class and everyone uses ChatGPT, so all of their answers are unique, but you can't just measure accuracy with those answers, right? So there are no certain evaluation metrics for LLMs. So you also have to control tone and start learning how to control hallucinations that an LLM can give. And then also you need system thinking, because industry really focuses on how you build a system. So I think these are the key skills that students has to have in current era.
Yeah, okay, Ravi. Thank you. Thank you for your giving a wonderful session. So, dear
Thank you.
participants, anybody have another doubt? Please ask, dear participants. Okay, Rahavi, thank you so much for giving the
Thank you.
wonderful session. Yeah, we learned a lot of things about the core concept of data science using LLMs. Okay, thank you so much. Thank you.
Thank you so much, ma'am. Thank you so much for having me today. So thank you for your interest and curiosity. Thank you.
Yeah, welcome, welcome. Okay. Dear participants, I shared a feedback form and one quiz form to our WhatsApp group. Kindly fill up the feedback form and the quiz also. Okay. So the response will close on today night 10 p.m. So kindly uh, put the feedback and quiz also. Okay. So thank you for your spending a valuable time with us. So we are expert and resource person on all of the numbers. Thank you once again.